we had stopped? I think I had told you to solve the remaining part of the problem yesterday, isn't it? Did anyone solve it? We were discussing, we were in the middle of a problem. We stopped yesterday in the middle of a problem, isn't it? Did anyone complete that problem? Did you find out the value of C1 and C2? Did anyone get the answer? Did anyone get the answer? Okay, Niharika, what's the value of C1? Minus 4 and 2. Any other answers? Two is correct. Yes, minus 1 and 2. Yes. Yes, Veeraj. Yes, Akshara. It is minus 1 and 2. Yes, Typhoon. It is minus 1 and 2. Very good. So did you substitute in the, after getting these values, just substitute in A of n, that formula, and we'll get the answer. That is our general solution. That is what we are aiming at. We are trying to find a general solution. So what is the final solution? And substitute in equation 1, isn't it? So you had the first equation as C1 plus C2 is equal to 1, and the second one was 2C1 plus 3C2 is equal to 4. This was our second equation, and this was our third equation. Then equation 2 into multiplied by 2, you multiply this equation by 2, so that you will get 2C1, and then if you subtract the C1 term, will get cancelled off. So multiply equation 2 by 2, you get 2C1 plus 2C2 is equal to 2. And this is equation 4. Then you can minus equation 3 minus 4. When you subtract equation minus 2C2, you will get what? 3C2 minus 2C2, you will get 1C2. That is C2 is equal to 1 minus 2, isn't it? 1 minus 2. Sorry, it is 3 minus equation 4 minus 2. You will get 2. Equation 3 minus 4. So 4 minus 2, you will get C2 to be 2. Isn't it? So we have found out the value of C2 as 2. Next, substitute the value of C2 in equation 2, you will get C1. Okay, substitute. Those who haven't done it, please complete it now. Substitute C2 in equation 2. You will get C1 plus 2 is equal to 1, or C1 is equal to 1 minus 2, that is equal to minus 1. So Niharika, please correct it, okay? Hello, Niharika. Please write it down. Okay, it is not minus 4, it is minus 1 and 2. Okay. So we have obtained the value of C1 and C. So our general solution, next after getting C1 and C2, we just need to substitute in equation 1. So general solution is, the general solution is, you have AN is equal to C1 R1 raised to N plus C2 into R2 raised to N. This is a general solution. The roots are different. So just substitute the value of C1 and C2 in this. You get C1 is minus 1. Isn't it? Minus 1 into R1, we have found out the value of R1. R1 is 2, isn't it? We have found out the value of R1 and R2. So it is R1 into minus 1 into 2 raised to n plus C2 is 2. 2 into, and our second root is 3. 3 raised to n. 1 into 2 raised to n is 2 raised to n. So this is our general solution. Okay, so we have to, the general solution, we have defined the general solution. If roots are different, this is our general solution. And in that, we have to find out C1, C2 after finding the roots, R1 and R2. So after finding roots, we can find out C1 and C2 given the initial conditions. Okay, and then after finding your C1 or a C1, C2 or an R2, the general solution. And did you complete it now? Did you write it down? Hello? So we had applied the second formula also. In the first case, what we had is you had a single real root. So we had to apply the formula corresponding to single real root. So in the second question, we had two distinct real roots. So we applied this formula for two distinct real roots. So for each, we are solving each case. First case was we have a single real root. Okay. Second is distinct, two distinct real roots. Okay, two different real roots. If you have a single root, then next case is two distinct real roots. Third case is we have two roots, two same roots. Okay, two same roots. Again, we are going to apply another formula. If we get roots, two roots which are both same, like if you're getting two roots like 2, 2 or 3, 3 or 5, 5. If you're getting two roots in this way, then we are going to use another formula. Here in two distinct roots, here we had 2 and 3 as two distinct roots. In our second case, we had two different roots. So we applied this particular formula. Then if you had the single root again, we applied the first formula. A single root means you have only one root, say it can be 2 or 3 or any one root. Then we have to apply formula corresponding to that single root. Okay. And that was an is equal to C1 R raised to n. That's all. Only this much portion will be there for there's one root. If there are two roots, we have to take two terms. Then if there are two same roots, then we have to apply another formula. So let us solve the third example corresponding to the third case. That is, we are having two same roots. Which formula can be you apply to get the general solution? Okay. Is it clear to you? Any doubts? Any doubts? If you have any doubt, just stop and ask, okay? Shall I proceed to the third case? See, why people are not joining first? It is 10 minutes past 8:15, it's 9 o'clock. Those who are missing these portions, they won't be able to understand anything. Okay. Please tell others to join first, and I'll be taking attendance soon. Now, shall I proceed to the next case? Hello? Shall I proceed to the next case? Did you write the question completely? Did you write the answer? Kaifal, Akshara, Akash. Okay, okay. So I'm going to the next case. Next case. Write the question. Third question. Solve the recurrence relation. Hello. Solve the recurrence. Solve the recurrence relation. Solve the recurrence relation. Fn. Instead of you can use any variable here. Depending on the question, you have to write that variable. If it is given an, you have to use an. If it is given fn, write fn. Fn is equal to 10f n minus 1 minus 25 f n minus 2. Okay, 25 f n minus 2. Where? So the question will be incomplete if initial conditions are not given. So initial conditions should be given for us to solve the question. So f0 is equal to 3 and f1 is equal to 17. Okay, solve this recurrence relation. Now, let us move on to the solution. So what is the first step? Like it is the same as the other question, only thing the formula is different. That's all. When we get two same roots, you're going to use a different formula to find the general solution. So what is the first step? You have to find out which kind of a relation this is, the given relation, isn't it? For that, you have to bring all terms to the, from in this is the question. So we have to bring all terms to the left-hand side. All the Fn terms should be brought to the left-hand side and check with which kind of a relation it is. Can you say which kind of a relation it is? What is the order of the relation? Bring all terms to the left-hand side and check which kind of a relation it is. And also, what is the order of the relation? Can someone say, read it? Agarsh? Isha is there? Which kind of a relation this is? To check if it is, to check the kind of the relation and the order of the relation, what you need to do is the easiest method, right? Bring all these Fn terms to the left hand side and check if something is there on the right hand side. What kind of a relation it is? No answer? See, this equation, this question, I can rearrange it as Fn, then this is equal to, so bring these terms to the right hand side. Okay, type it is homogeneous. Why do you call it as homogeneous? Fn minus 10f n minus 1 plus 25 f n minus 2 is equal to, is there any term left on the right hand side? No, it is equal to 0. I had brought all these fn terms. This is one fn term. This is the coefficient of fn term. So I have brought all these fn terms to the left hand side. Fn minus, when plus 10 fn goes to the other side, it becomes minus 10 fn minus 1. And plus 25 fn goes to the other side, it becomes plus 25 fn minus 2 is equal to 0. Okay, so since the right hand side is 0, this equation is homogeneous. It is linear, isn't it? Is it linear? You look at the Fn, the coefficients of Fn term, everything is constant. So we say it is a linear, homogeneous recurrence relation of order. What is the order? Can you find out the order? How do you find out the order? Very good, 2. Just subtract this n and this n minus 2, the highest and the lowest, that is n minus of n minus 2. You get n minus n plus 2. This will cancel and 2. The order of the relation is 2, which means you will have two roots. Okay, so it is a homogeneous recurrent. It is a second order. 2 means it is a second order homogeneous recurrence relation. It is a second order homogeneous recurrence, second order linear homogeneous recurrence relation. Okay, so once you are given a question, just find out the order and whether it is homogeneous or not. And we are finding this out so that if it is homogeneous, we are applying the formulas which we are doing now. If it is non-homogeneous, we cannot apply those formulas. We have to apply other different formula, and that will come across in the next section. We are finding out the order so that you will be able to find out how many roots are there. If it is second order, then you will get 2 roots. So to find out the two constants, you will be given two initial conditions also. From this question, you will be able to understand how many roots will be there. Now our aim is to check if the roots are same or different. Okay. We have to find out the roots. And how will we find out how can we find out the roots? The first step is to write the characteristic equation, isn't it? Write the characteristic equation. Step 1, you have to write the characteristic equation. I think you can solve it by yourself if you have done 2 questions, if you understood how to do 2 questions. So to write the characteristic equation corresponding to fn minus 10fn minus 1 plus 25fn minus 2 is equal to 0. This is the equation that is given. To write the characteristic equation, just substitute instead of f, you just write r and bring this n to its power. Then the remaining are the same. This f again substitute it by the root r and then bring its suffix to its power. Plus 25. Instead of f, you write r and bring this n minus 2 to its power is equal to 0. And then subtract this lowest power throughout the equation. Subtract all terms by this lowest power. Okay, when you subtract it, you get what will be the first term? R raised to n is not subtract, divide. Okay, divide by r raised to n minus 1. Divide this equation by r raised to n minus 1. What will you get? The first term. What is the first term? Come on, do it first. R raised to n divided by r raised to n minus 1. R raised to n minus of n minus 1. What will you get? Sorry, it is n minus 2, right? The lowest term is this, that is n minus 2. So, n minus 2. So, you will get r raised to 2. So, r raised to 2. The next term, minus 10 into r raised to n minus 1 divided by r raised to n minus 2. What will you get? R, 10r. Very good, Typha. 10r plus 25. R raised to n minus 2 divided by r raised to the whole thing will cancel. You get 25 is equal to 0. Now find out the roots. Which formula will you apply to find out the roots? R is equal to, you will get 2 roots. Since it is of order 2, you will get degree 2. The polynomial is of degree 2. You will get 2 roots. R is equal to minus b plus or minus root of b square minus 4ac by 2a. Find out the roots. Find out the roots. Here, what is a? A is the coefficient of r square 1. Then b is the coefficient of r, that is minus 10. And c is the constant term, that is 25. Now substitute these values and find out the roots. Come on first, find out the roots. Give me the answer. Yes. Very good, Typha. How many roots? How many roots? You got r is equal to 5, comma 5. You will get 2 roots, isn't it? 2 roots and 2 roots are same, isn't it? Did you get roots like this? You have 2 roots, one root is 5, r1 is 5 and r2 is also 5. The order of the equation was 2, so you will get 2 roots and the 2 roots are same. The 2 roots are same. The 2 roots are same. So if the 2 roots are same, then the general solution, is, here instead of an, we can write the variable given as fn. So fn is equal to c1 plus c2n into r1. r1 is equal to r2. So you can just write r raised to n. Since we are getting a single root, even if you write r1 here or r2 or simply r, you just substitute, you have a single root and you apply this formula. Okay, this is our general solution. No, if from this general solution, now what we have to compute? We have got the value of R, isn't it? R we have found out it is 5. We know this value. Now next we have to find out C1 and C2. Now how will we find C1 and C2? How are we going to find C1 and C2? Can anyone say how we will find C1 and C2? Something is given in the question. To find these constants, some values are given in the question. What is given? What is given in the question to find C1 and C2? Anyone? Yes, very good, Agarsh. The initial conditions. Initial conditions given are F0 and F1. So F0 is given. So put n is equal to 0. So to find C1 and C2, we are going to find C1 and C2. Put n is equal to 0. Isn't it? When we put n is equal to 0, what will we get? When we put n is equal to 0, you get F0 is equal to C1 plus C2. And when we put n is equal to 0, this you can multiply here by 0 into R raised to 0. Isn't it? Now what will you get? F0 is equal to, this term will become 0. It will be C1, and for any number raised to 0 is 1. So F0 is equal to C1, and value of F0 is given in the question. What is F0? What is the value of F0? F0 is given, right? What is the value of F0? What is the value of F0? Come on fast. 3. Yes, so I have found out the value of C1 as 3. Now I am given another initial condition also, that is F1 is also given. So next put n is equal to 1 in the general solution. You get F1 is equal to C1 plus C2n. Instead of n, I am putting 1 into R raised to 1. This becomes C1 plus C2, the whole into 5. Isn't it? Now I have the value of C1, isn't it? I have found out the value of C1. I know the value of F1 also. So I know the value of F1. It is given in the question as 17 is equal to 3. C1 I have found it now. I found the value now, plus C2 into 5. From this you can find out what is C2, isn't it? What is the value of C2? What is the value of C2? Did you get the value of C2? 5. C2 is equal to 2. C2 is equal to 2 by 5. Isn't it? Did you get this? Very good. 2 by 5. Now next we can go on to our general solution. Now we have obtained, we know the value of R, we know the value of C1, and we know the value of C2. So just substitute in the general solution for the equation that corresponding to those having same root. That is, you have Fn, the equation is C1 plus C2n into R raised to n. So you know value of R, C1 and C2, and just substitute. That is equal to, what will you get? C1 plus C2n into 5 raised to n. Or you multiply the term C1 into 5 raised to n plus C2 into n into 5 raised to n. I'm just opening this. Then the value of C1 is 3. So 3 into 5 raised to n plus C2, we got it now as 2 by 5 into n into 5 raised to n. So this is the answer. Okay. See, you can solve it again. That is, if you cancel 1 5 here and you are cancelling 1 5 from this, then you get n minus 1. So you'll get 3 point or either you can leave it like that, or you can solve it as 3 into 5 raised to n plus 2n into 5 raised to n minus 1. 1 5 I'm cancelling from here. Okay. Did you understand? So this is the formula that we apply for finding the general solution if roots are same. Is it clear? Is it clear to you? Any doubts? Hello? Any doubts? Do you have any doubts? Anyone? Please respond. So this was another case, isn't it? We are discussing each cases, okay? First one was we had a single root. Second case is we have two different roots. Third case we have two same roots. Okay, the third question is based on having two. The roots that we obtained is of order two. That is, we have two roots, but they are both the same roots. Okay. Akash, did you understand? Taifel? I'm asking to everyone, but since these students are responding, I'm just calling their names. Others also can respond. Okay. Hello. Those who joined in between, it will be very difficult for you to follow. See, all these cases which I'm telling now, you have to study it. Okay, it's very important from examination point of view, even from for your series examination point of view. Each of these cases is important. Study these cases well. Study the method well and try to solve it. You will get full marks if you solve the question correctly. Okay. See, another point I want to say is I had given you certain questions on Hasse diagram, isn't it? From third module, I had given you questions to write it down in your tutorial book. I will be uploading the the assignment in Linways today. You have to upload the answers. I had told you to submit it last week or before online classes, I think, before starting the online classes. So just take the photo and upload it in Linways. Okay, is it clear? Is it clear? And I'll be setting the time till tomorrow 12. That is your assignment from module 3, the Hasse item. It is important for the series exam also. So if you haven't done it, please study it and then write the assignments and upload it. It is important for your series. It is very useful if you do it today. Today or tomorrow. It's there for your series exam also. And another thing I want to say is those who had failed in series exam, write the question paper, solve the whole question paper. Okay. And again, I'll be uploading it as an assignment and you have to upload the answer sheet. Those who are not present also tell them that they should do it. Write the solve the question paper and I will be uploading the answer key in Linways. Look at the answer key, study the answers well, and then solve the question paper. Okay, series 1 answer key, I will be uploading the solved answer key. I will upload in Linways. Study that answer key well, and then you write it down in your tutorial note, and then upload it in Linways. Okay, that also I will be uploading as an assignment, so you can upload it there. And those who passed the exam, series exam, those who had passed the exam, solve those questions which you scored 0 marks. Okay. Solve those questions which you haven't attended. Is it clear? So all of you have to attend the questions. Those who had failed should write the entire question paper, and those who had passed should write only those questions which you didn't attend. Is it clear to you? There is no choice. You have to answer without choices. So those who had passed, just solve those questions which you haven't attended. Is it clear to you what I said? Is it clear to you what I said? And I hope if those who are interested, you may join tomorrow at 6 p.m. so that I can discuss the series 1 question paper. And then you can, if you write it, it will be useful for you. Okay. Rather than copying from my answer key, you just listen to the method to solve it and then write it down. Okay. Is it clear? Is it clear to you? Did you understand what I said? Okay. So first two modules are very easy, so you can score good marks. And even this module is also easy if you study all the formulas. And formulas are not that difficult to study; they are all direct formulas. You just write down the case one, case two, etc., and study the formulas and solve. The same method is followed for every problem. Okay. So anyway, just try to solve some problems. Try to work hard a little more, and you can pass very easily. And if you have any doubt, you can call me anytime and ask. If you want to take classroom class via this Google Meet also, two or three people can join and then inform me. I will conduct class via this Google Meet. Okay. If you have any doubts, please ask me. Okay, later. Then I told you to come and get the answer sheets, and you didn't come and get. Only 3 students came to me. Now let us move on to the next type. Okay, the last type in homogeneous recurrence relation. So we are going to discuss the fourth type in homogeneous recurrence relation. With that, we'll come to the end of homogeneous recurrence relation. Then we will go to, after that, we'll go to non-homogeneous recurrence relation. Okay, solving non-homogeneous recurrence relation. So in homogeneous, we have 4 cases. And in non-homogeneous, again, we have very different cases. Okay, so this is the fourth case in homogeneous recurrence relation. So let me solve it as question 4. Okay, write down question 4. Solve the recurrence relation. Solve the recurrence relation. Fn is equal to 2fn minus 1 minus 2fn minus 2. Solve this recurrence relation. Is this enough for our question? Is the question complete? Is this question complete? No. Why? Question is not complete. Why? What else we need? What else we need? Very good. Initial conditions where F0 is equal to 1 and F1 is equal to 3. Okay, so we are going to solve this. We are going to find out the roots, just like what we had done before. We will first write the characteristic equation, find out the roots, and then we look at the nature of the roots. Whether we have a single root or whether we have 2 same roots or 2 different roots. And those are the 3 cases which we discussed. And in this 4th case, we find that the roots are imaginary. In this case, this is case 4, isn't it? Case 4, we find that when we solve this equation, we find that the roots are imaginary. If the roots are imaginary, what is the general solution? We have another solution. We have the general solution differs. What is that general solution? And then we write the general solution and then find out the constants and then substitute. Okay, so the general solution differs for each case. The last cases, roots are imaginary. Again, we have another general solution corresponding to the imaginary roots. We write that general solution and then solve it. Okay. Is it clear? Is it clear to you? The 4th case, in the 4th case, we have roots as imaginary roots. Okay. Let us see whether the roots are imaginary or not. Is it clear? So what was case 1? What was case 1? Single real root. Okay, and the general solution was C into R raised to N. An is equal to C into R raised to N. Then case 2, two distinct roots. We have An is equal to C1 R1 raised to N plus C2 R2 raised to N. Case 3, two same roots. Then the general solution An is C1 plus C2N into R raised to N. Now, these were the three formulas we studied. When we obtained these kinds of roots, we applied these formulas, found out the constants and the root, and then we substituted in the general solution to get the final answer. Isn't it? Did you understand the three cases? Did you understand these three cases? Hello? Okay, Adarsh. Okay, so now we are going to solve the fourth case. With that, we'll come to the end of homogeneous recurrence relation. Okay. So this is the question given. So now, just like we solved the other question, we have to do till we get the roots. Okay. So given, so answer. Given what Fn is equal to 2f n minus 1 minus 2f n minus 2. This is given. This is a question that is given. Now, what are you going to do? Bring these terms to the left hand side. So Fn minus 2f n minus 1 minus 2f n minus 2 is equal to 0. Nothing is there. So this is a homogeneous recurrence relation of order. What is the order? Order of the recurrence relation. What is the order of this recurrence relation? Come on fast. What is the order? 2. Very good. So it is a second order linear. Linear since the coefficients are constants. Linear homogeneous. Homogeneous because the right hand side is 0. Homogeneous recurrence relation. Isn't it? So since it is second order, you will have two roots. Now next write the characteristic equation. Characteristic equation. To get the characteristic equation right, just substitute this. Instead of f, you write r and raise to the power of its suffix. So characteristic equation, you get r raised to n minus 2 as such. Then instead of f, you can write r raised to n minus 1 minus 2 into, instead of f, write r raised to n minus 2 is equal to 0, and then divide by r raised to n minus 2. Divide this equation by r raised to n minus 2. What will you get? What will you get when you divide? What will you get? R square minus 2r plus 2 is equal to 0. Now, find the roots using. Find the roots. Just, you know the formula R is equal to minus b plus or minus root of b square minus 4ac by 2a. Okay, we'll continue in the third period. I'll be taking the third period. Now say your attendance. Say your attendance. I didn't hear the first number.
1,
2,
Next. Number 3. 4. 4 absent. 5.
5,
6,
7,
8,
10,
12, 13,
15.
16, 17 present. Next 18.
18.
19 present. 20
21.
present. Okay.
22.
23.
24,
25,
26,
27.
28. 28 absent.
30,
31.
32,
33,
34.
35.
36.
37,
37.
38,
Number 37. 38.
38,
Okay. 39. 39 absent.
40,
40.
41.
40,
Okay. 40 present. 41
42,
present.
43,
Okay. Okay.
44,
Okay. 45 present.
46.
48.
47. 47 absent. 48 present. 49.
49.
50 present. Okay, 47 present.
51.
51 present.
52,
Next.
53,
54 present.
55. 55.
Okay. Okay.
56.
57.
58 present.
59.
50,
60.
60.
62.
61 present. 62 present. 63 absent. So absent is number 28, number 39, and number 63. Okay, thank you. Thank you.